All right, this lesson is going to cover stoichiometry of gases. All right, and so we've kind of mentioned this in a previous video, but this deals kind of with Avogadro's hypothesis. So there's Amedeo Avogadro. Basically, what it states is that equal volumes of gases that have the same temperature and the same pressure contain equal numbers of particles. And so this is like atoms or molecules. All right, so you might say, all right, well, what's that significant of? Well, here's what's kind of confusing at first, okay? And let's say I have three different gases there. I have argon, oxygen, nitrogen, okay? As long as you have the same quantity, okay, so 1 mole, all right, this idea of a mole of gases. So if I have 1 mole of each and they are the exact same temperature, the exact same pressure, so notice they're all at 1 atmosphere and 273 K, their volume is identical. All right. And so there is a standard. It's called the standard molar volume of a gas. So you need to know this at STP. And STP is standard temperature and pressure. Okay. Standard temp is 0 degrees Celsius, or it's 273 K is essentially what it is. And then that pressure is all these things like 1 atmosphere, right? 760 torr, 760 kilo, or not kilopascals, millimeters of mercury. And then like 101 kPa, okay, all these things. So anyway, 1 mole of any gas, as long as it is at STP, has a volume of 22.4 liters. I don't care if it's helium atoms or if it's sulfur hexafluoride molecules. Gases are spread so far apart, it doesn't matter how large the atoms are. There's so much space between them, it's independent of it. Okay, and so what you need to know, this is kind of like our mole map we did before. All these things are interrelated. So particles are related to the mole, right? Avogadro's number. Molar mass is related to the mole. And then this 22.4 liters. But then you also have to be aware this is only at STP. All the problems we will do will be at STP. So probably the easiest way for me to do this is just run you through some. So these are gas stoich problems. So it's just basically a review of things we've already done with this last little twist. Okay, I want to know how many liters of hydrogen are produced. So I have 225 grams of iron reacting with hydrochloric acid, assuming the reaction takes place at STP. First thing you got to do is balance it. Okay, and just like any stoich problem, so there you do. You slap a 2 in front of the hydrochloric and it's good. So we start with what we know, 225 grams of iron. And we're trying to get to volume of hydrogen. Well, the only relationship I know between iron and hydrogen is their molar relationship. For 1 mole, I get 1 mole. So I need to make this moles. If I have a mole of iron, it weighs, according to the periodic table, 55.85 grams of iron. Grams cancel, I now know moles. Now that I know moles, I can do my mole ratio. For every mole of iron, there's 1 mole of hydrogen. Okay, now we know moles. Well, because we know that it's at STP, we know the volume of 1 mole, don't we? We know that 1 mole at STP of any gas is 22.4 liters. So we have converted grams to now liters. All we need to do is solve 225 times 22.4 divided by 55.85. You're going to have 4 sig figs because of the 4 here. That answer is going to be 90.24 liters of hydrogen. Okay. We don't use any of these conversion factors for sig figs. 22.4 doesn't count because it is a constant. It is not a measurement. Okay, another one. Let's say I want to know what volume of chlorine gas at STP is necessary to completely react 4.81 grams of sodium. Once again, you're going to start by balancing. You put a 2 here and a 2 here, and we're good. Start with what we know. 4.81 grams of sodium. Well, first thing I need to do is make that moles. I know that every mole of sodium weighs 22.99 grams of sodium. That's just its molar mass from the periodic table. Now I know moles, I can do my mole ratio. Well, the relationship here is for every 2 moles, it reacts with 1, right? So every 2 moles of sodium will react with 1 mole of chlorine. Moles cancel. Now I know moles of chlorine. I want to know volume at STP. Well, 1 mole of chlorine at STP has a volume of 22.4 liters. Moles cancel. I'm ready to solve. 4.8 times 22.4 divided by 22.99 divided by 2. When I do that, I'm going to have 3 sig figs because of these 3. 2.34 liters of chlorine. Okay, you're going to have to be able to do one of these on the test, right? Where I give it to you in the word form, so you have to know how to write a formula equation again. So hopefully you've remembered how to do this skill. So a magnesium metal, that's just magnesium, reacts with hydrochloric acid, HCl, and it produces, what does it say? Magnesium chloride. Oh, my pen stopped working. Let's see here. See if, there we go. There's your hydrochloric acid, so magnesium chloride. You have to remember magnesium is 2 plus, chlorine is 2 minus, so it's MgCl2. And then hydrogen gas, don't forget Brinkelhoff, right? Those go to 7, make a 7, those elements that are never found by itself, so you need a 2 there. So you need to be able to balance the formula, write the formula equation before you balance it. All you need is a 2 here. Let's see, and it doesn't say, but we're going to assume it's at STP. All these will be at STP. 5.25 grams of magnesium, and I'm trying to find the volume of hydrogen, so I need to make this into moles. 1 mole of magnesium is 24.31 grams of magnesium. Grams cancel, I now know moles. Now that I know moles, I can do my mole ratio. Well, for every 1 there is 1, right? So that's easy enough. 1 mole of magnesium will give me 1 mole of hydrogen gas. Moles cancel. Now I need to know its molar volume. Well, just like anything, 1 mole of hydrogen gas is 22.4 liters of hydrogen. Moles cancel. 5.25 times 22.4 divided by 24.3. You're going to have 3 sig figs in your answer. Oops, hold on. 3 sig figs in your answer. 4.84 liters of hydrogen. And that's basically it. So I'll give you guys some to practice.